Hi everybody. We're going to work on this worksheet together for textbook section 4.3 box plots. You can see I have here two groups of data. We're going to focus on using group 1 in this video, and then I'd like you to work on group 2, and then you'll be able to see how to do this work with a different set of data. So for each group, and so in this video, group 1 only, we're going to first of all find the quartiles, which are quartiles 1, 2, and 3. We're going to then find the interquartile range, and we're going to create and draw a box plot from this data that we'll call a 5-number summary. So let's get started. So group 1, let me write it again here. 1, 3, 5, 7, 9, 11, 13, 15, and 17. All right, so to find Quartile 2, that's what we find first, and it's the middle of the ordered data. So if you count up these values, there's 9, which means I have a middle, and it's right here at the number 9. So it's the same as the count of values. There's 4 numbers smaller than 9, 1, 3, 5, and 7. There's 4 numbers larger than 9, 11, 13, 15, and 17. That's why 9's in the middle, and it's Quartile 2. Now we find Quartile 1. I'm going to change my pen color because I want to find the middle of the observations, which are the data values, below the median Quartile 2. So numbers that are smaller than 9, that's what I'm looking for Quartile 1. I'm looking at 1, 3, 5, and 7. There's 4 values there, so there's an even number, which means I don't have a middle. But I have 2 numbers in the middle. So to find Quartile 1, I will take 3 plus 5 and divide it by 2 because I'm finding the average, or 8 divided by 2, which is 4. So Quartile 1 is 4. I want to do the same thing now to find Quartile 3, but on the other side of 9. I want to look at the values that are larger than 9, that are above the median Quartile 2. They are 11, 13, 15, and 17. Well, 13 and 15 are the ones in the middle. There's again only 4 values, so there's no true middle. So Quartile 3 will be found in the same way that I found Quartile 1. I'll be adding the middle numbers, 13 plus 15. Let me fix that. There we go. And divide it by 2. So I have 28 divided by 2, which is 14. I found my quartiles. Those are 3 numbers in what's called the 5-number summary. Let me move things up a little bit. And I'm now going to find the interquartile range for group 1. So the IQR is Quartile 3 minus Quartile 1. So you can see above at the top of this page, Quartile 3 is 14. Quartile 1 is 4, so 14 minus 4, that's 10. That's going to be the length of the box in the box plot. So we're now to the part where we're going to create a box plot. I wrote the 5-number summary that we found in part 1 of this video. And you can see there's the 5 numbers. We're going to use these when we draw our box plot. I'm going to make a horizontal line here, start the scale at 0, and then you can see I just have to go up to 17, but I'm going to go a little bit higher than that, and I'll explain why in a second. So make that about 10, this about the same distance to 20, and then let me extend this a little bit, and we'll go to 30. Now again, why am I going so high? Because my group 2 box plot, it will be good to use the same exact scale as group 1. That way we'll be able to compare the box plots directly. Compare the left side and the right side, and where the median, or Quartile Two, is. The Group 2 has a larger range of values, so the high value in Quartile 3 will be bigger than Group 1's. So what we do here is I'm going to put a little bit more detail to this number line. Bear with me a little bit. So let me cut each of these in half. I'm not too good at this. It's a little better. I think part of it is my stylus has this big thick tip on it and it's hard to see exactly where the line's being drawn. That's my excuse anyway for not being able to draw well. Alright, so I added the rest of the little number tick marks here so you wouldn't have to see how long it took me, because it took me forever. And now what I'm going to do is at my low, which is 1, I'm going to put a little dot, and at my high, which is 17, which is right there, I'll also put a dot, about at the same height as where the dot was for number 1. At Quartile 1, which is 4, that's right here, I'm going to draw a vertical line. I'm starting to produce my box. That's the left side of the box. At 9, my median, I will also draw a vertical line. And at Quartile 3, which is 14, which is right here, I'll draw a third vertical line, which is the right side of my box. Let's draw the box, drawing the top and the bottom, and there you go. I'll also draw a line from the dot at 1 to the box, as well as from 17 to the box. This plot is also called a box and whisker plot, and those are the whiskers. That idea of whiskers, kind of like if the middle was the face of a cat, and then the whiskers coming outside, out from either side. Go ahead and do this work for Group 2 also, and you're going to see how the box looks different. Before we do that, though, we have one more thing to do here, which is to move the page up a little bit, and we're going to talk about outliers. We calculate outliers by looking at two numbers, and we're going to look at what's called the left fence and the right fence. Let's remind ourselves, what is Q1, because we're going to need that. Quartile 1 is where the box begins, and it's the number 4. Quartile 3 is where the box ends, and for Group 1 it was 14. And then I also need my IQR. IQR was 14 minus 4, or 10. So to get this idea of this left fence, basically the lowest number that we consider to be a usual value, we'll take Q1, which is 4, minus, and I'm going to put in parentheses, 1.5 times the IQR, which is 10. So we'll have 4 minus 15, which is negative 11. Because there's no values, and we're talking about data values, less than negative 11, there are no outliers on the lower end. We're going to do the same thing for outliers on the higher end, which we call the right fence. Any values that are larger than this right fence, that are data values in the original data set, they would be considered outliers. Basically, the right fence determines like the largest, what we can again call usual value for this data set. We're going to take Q3, which is 14, and we're going to add to it 1.5 times the IQR, which is 10. So 14 plus 15 is 29. And there's no values more than 29. What's the largest value in this data set? It's 17. So what does that mean? There are no outliers on the higher end. So please reproduce all of this data, this work, finding the quartiles, calculating the IQR interquartile range, drawing the box plot, and determining the left and the right fence to find if there's any outliers. Do all of this for group 2 and see how it goes. Bye.